All right, here's another lesson in our maths, and we'll look at now factorization. So we put topic here, factorization. Now, this is just going to be basic factorization so that you can get a hang of it, and then we're going to do two different types of factorization afterwards, which is a little bit more difficult, but it should be easy anyway. So the first question you want to answer is, what is factorization? So put this here. What is factorization? Factorization is just simply a technique that we're going to use to simplify expressions and to solve equations. So let me just write that note. This is a technique used to simplify expressions and solve equations. And then once an expression is factorized, it is expressed as a product of its factors. So let me give you a little bit of an example of what that means. So let's say, I'll put this in orange. Let's say if e of x is a polynomial that can be factorized, then we can say that e of x can be written as a of x times, I'll put a dot in between there, times b of x. Alright, now a of x and b of x are just simply factors of e of x. So you say that these here are factors of e of x. Right? To determine the factors of a polynomial, we need to know the HCF. And the HCF is the highest common factor that you're familiar with, and you should already know how to determine the highest common factor, or the HCF, with your prime factorization method, or you're supposed to learn how to do it with your regular division method. Let's go ahead and do a simple example of that. So put here this, and we can say to determine the factors of a polynomial, we need to determine the highest common factor of the terms of the polynomial. Put that in white again. Right? So let me give you an example of that. Let's say, for example, we're required to find the HCF of 12x cubed y squared and 18x squared y cubed. The first thing you want to do is you want to find the HCF of 12 and 18. Now, just a quick reminder, there are two methods that you can go about doing to solve this, and I'll do both of them now. So one is the prime factorization method, where you break up the numbers into prime numbers, a product of prime numbers. So we can say 2 times 2 is 4 times 3 is equal to 12. Then for 18, we have 2 times 3 times 3 would be equal to 18. So this is 2 to the second power, and this is 3 to the first power. And this is 2 to the first power times 3 to the second power. Now what you do is you take the lowest common of the factors. So this here is 2 to the second, this is 2 to the first, so we're going to take 2 to the first as the lowest common to 2's. So 2 to the first times, then we have 3 to the second, 3 to the first, the lowest common for 3's is 3 to the first, so that means our HCF is 6. 2 to the second is 2 times 3 to the first, or 2 to the first power, sorry, is 2, and then 3 to the first power is 3, so this is 6. And then we can also do it like this, where we take 18 divided by 12, and we will get 1 remainder 6, and then we take 12 divided by 6, and we get 2 remainder 0. And since we get this remainder 0, it means 6 is the HCF. Right? So we know that HCF is 6 so far. So HCF of terms, and I'm referring to the terms above this here and this here. So first we get the HCF of the numbers, which we already identify as 6. Then we take the lowest of the powers for the common variables. So x is a common variable, and the lowest common is x to the second. So x to the second. Similarly for y to the second, y to the third, the lowest power between the two of them is y to the second. And this here is the HCF of the terms 12x to the third y to the second and 18x to the second y to the third. So now that we know how to get the HCF of the terms, let's go about learning how to factorize expressions with the HCF. So let me outline some steps here for you. So we say steps for factorization, and step 1, we're going to say determine HCF of all terms in the expression. And then once you do that, you're going to find the greatest common divisor of coefficients. Right? We're looking at the greatest common divisor of the coefficients, which is, in this case, it would have been 6. So coefficient 12, coefficient 18, the HCF is 6, greatest common divisor is 6. And then next we're looking at identify the lowest exponent for each common variable, right? Yeah, so identify lowest common exponent for each variable, for each common variable. And then we go to step 2, which is to factor out the HCF from each term. Oopsie. Term, and then the last part is to write the expression as the product of the HCF and the simplified, oopsie, too long, simplified expression. All right? So those are the 3 steps, and it's a very simple set of things to do. So we're going to do some examples now. I'm going to do about 5 examples, and then I'm going to give you problems that you can work on your own time. So let's first look at an example. We just put in a new page, and example 1. I just put example. First example is to factorize, well, all of these is factorization problems. So factorize 5x plus 10. So first thing we do, we find the HCF or the GCD of 5 and 10. To do this, we just simply take 10 divided by 5. We get 2 remainder 0. This remainder 0 tells us that 5 is the HCF. So we have so far 5 as the first part of the HCF. We notice that we have no common variables. So that means 5 is the factor that we're looking at. So I put a piece of bracket here. And then what I do is I determine what goes in the bracket. So I take each of the terms, so this term here and this term here, and divide it by 5. So I say 5x divided by 5. 5 will cancel, leave me with x. I take that x and I put it in here. Then I take the positive 10 divided by 5. That gives me positive 2. So I take that and put it in here. All right, very easy to do. And this is the factorized form. You can test if it's a factorized form by simply using distributive law and multiplying these back out. So in other words, I'll take this, multiply by this, and multiply by this. If I can get this original expression here, then that means I factorized correctly. All right, so in the problems that you'll get at the end of this, you can factorize and then multiply it back out. And if you get this exact same answer up here, then you did it properly. All right, again, let's try another one. Example 2. So with example 2, let's use 7x squared minus 14x. All right, so we need to find the HCF of 7 and 14. Okay, so we take 14 divided by 7, we get 2 remainder 0. So that means this remainder 0 tells us that 7 is the HCF. We're looking at common variables. We're seeing that x is something in common. All right, we're seeing that x is something in common. So let me put out this 7 here first. We're seeing that x is something in common. We see that the lowest exponent of the x is 1. So then that means we put x here. And then after that, we open brackets and then we simplify. So I'm going to take each term here and here and divide it. So I'm going to take 7x squared divided by 7x. 7 cancels, x cancels, remain with 1x. That x goes here. Then we take negative 14x divided by 7x. X cancels, and then 7 cancels here to give me 2. So this is negative 2. So then negative 2 goes here, and that's the answer. All right, let's do another one really quickly. Example 3. At this point in time, if you figure out that you know what you're doing, you can try and solve the example before me and see if your answer is correct at the end of it. So 9xy plus 12xz. And first off, we look at the HCF of 9 and 12. So we're seeing 12 divided by 9 would be equal to 1 remainder 3. Then we see 9 divided by 3 is equal to 3 remainder 0. So that 0 here means that 3 is the HCF. So first we're seeing 3 in common. Now let's look at the x's. We see that x is in common to both. The lowest power is x. So we say, okay, 3x. We see that y is not common to both. We see that z is not common to both. So we ignore them. And then this is the factor here. We're going to divide each of the terms by. So I'm going to take this here and this here and do the division. So I'm going to say 9xy divided by 3x. X here, 3 here. I get 3y. I put that in here. Then I take 12xz divided by 3x. Cancel here. This is 4. I get 4z. So that means positive 4z. Oopsie. We'll just put this in a different color here. All right, and that's the answer for it. Let's go on to another one. So let's say example 4. Let's do something a little bit more difficult or challenging now. Let's say we have 16x to the 4th power, y to the 2nd power, minus 8x to the 3rd power, y to the 3rd power, plus 4x to the 2nd power, y to the 2nd power. So we need the HCF of 16, 8, and 4. In this one, I can't use the division method. I have to use the prime factorization. So let me see. 16 is simply 2 times 2 times 2 times 2. so which is 2 to the fourth power. 8 is simply 2 times 2 times 2, 2 to the third power, and then 4 is simply 2 times 2, which is 2 to the second power. From this, we can see that the lowest common, so the common base here is 2. The lowest base of 2, lowest power, sorry, of 2 is 2 here. So then that means the HCF is 2 to the second, which is equal to 4. So I put 4 outside here. Then I observe the x's. So x4, x3, x2. x2 is the lowest, so put x2 here. Then we have y2, y3, y2. y2 is the lowest, so we put y2 here. And then brackets, and then each one of these needs to be divided. So I'm just going to do this underneath here. So 16x to the fourth power y to the second power divided by 4x to the second y to the second. Cancel here remain 2, cancel here remain 4. So I'm going to get 4x to the second power, which I put over here. Then I have negative 8x to the third y to the third divided by 16x to the fourth y to the second. So cancel, leave 1 here. Cancel, oopsie, that's not to the fourth, this is to the 2. Y to the x to the 2, right? Then cancel, leave 1 here as well. And then this here is supposed to be 4. I wrote the wrong thing on the denominator. 4. Alright. So 4 into this 1, 4 into this 2. And we get 2, wait, okay, the negative sign, 2xy. Alright, then we do the final one, which is positive 4x squared y squared divided by 4x squared y squared. This cancels here, this cancels here, this cancels here, and we get a positive 1. So then we have negative 2xy, and then we have positive 1, and this is your answer. Alright? Now, most of the time, these here done mentally. Alright? After a while, you can start seeing what the highest factor of a number is. Alright? So this here is usually done mentally after a while. If it is you can't do it mentally, then you can go ahead and write it in. After that, this here is usually also done mentally. I recommend that you still use it though, because it makes it easier for you to learn the process and be able to do your cancellations faster. You can leave it in your mind or you can write it out, your choice. But quite frankly, you go from here to here most of the time. I'll do the last example like that. I'll just go from the what I need to factorize to the answer. All right, so let me see. Example, let's say we have 18 a to the third power b to the second power minus 27 a to the second power b to the third power plus 9 a to the second power b to the second power c. All right, if I have to work out the HCF of 18, 27, and 9, I know that 9 is the highest it could be. I know 27 is a multiple of 9. 18 is a multiple of 9, so therefore HCF has to be 9. So I put 9 here. Then lowest power of A, since A is common to all of them, is A to the second. Then lowest power of B is B to the second, since it's common to all. And then C is not common to all, so I ignore it. Then I simply take 18 and divide it by this in my head. And I can see 18 divided by 9 is 2. 2 A's here, 3 A's there, leaves 1 A remaining. 2 B's here, 2 B's here, that means no B is remaining. Then we see 27 divided by 9, which is 3. And then we say 2 A's here, 2 A's here, no more A's. 3 A's here, 3 B's here, 2 B's here, then that means 1 B remaining. Then put a plus sign, since that's a plus sign there. Then 9 cancels with 9. Then A2 cancels with A2, B squared cancels with B squared, and C remains at the end of it, and this is our answer at the end. All right, so you don't need to work out all this extra stuff here. All right, you don't need to work out all this extra stuff. But if you do it a few times, then you're going to get in your mind what you have to do. And once that happens, your mind will start taking over and you will just do all of this in your head instead of actually having to write it out. All right, so even though you don't need it, still write it out a little bit just to get familiar with it. Let me give you some problems and that would be the end of this lesson. So problems, we can say we'll start off simple and then we go complex. So 6x plus 12, let me get to the next one, 8x cubed minus 4x squared. Then let's see, 14xy minus 21, say 21, xz. Let's see, number 4. Let's see, 24x to the 5, y to the third, minus 16x to the fourth, y to the fourth, plus 8x to the third, y to the third. And then number 5 is 30x to the fourth, let's say b to the third, c minus 45, a to the third, b to the fourth, c to the second, plus 15, a to the third, b to the third, c. Right? That should be a good complex one for you to do. Once you finish this, no problem. You learn factorization. The next one we'll do factorization by grouping.